Number 57, what is the effect on the graph of f of x equals 2x plus 5 when g of x equals 2 times 3x plus 5? So these are our transformations. I talked about this a little bit on 56. Transformations are when you change a function with addition or subtraction or multiplication. If you're changing a function with addition or subtraction, that will be your shifting left or right, up or down. We call that translating a graph. If you are changing a function with multiplication, then we think through, would the slope change, would the y-intercept change, kind of those things. So we have to identify how our function has changed. So the original function is 2x plus 5. So when I look at g of x, I can see here's the 2, and instead of a 2x, there's a 3 being multiplied in with the x, and then that plus 5 on the end did not change. So what we're doing is we're multiplying the x by a 3, and let's just see what that does to our function. So we can simplify g of x. 2 times a 3x is 6x, and that plus 5 would just carry along. All right, let's look at our options and see what we agree or disagree with. The graphs of g of x and f of x have the same slope. So f of x has a slope of 2, g of x has a slope of 6. Those are not the same, so we won't pick that. The graphs of g of x and f of x have the same y-intercept. So f of x has a y-intercept of 5, and g of x has a y-intercept of 5. So we do like that one, but let's just read through the rest of them to make sure that that is our best choice. Option C, the slope of the graph of g of x is 3 times the slope of the graph of f of x. So is 6 3 times a 2? It is. The y-intercept changes from 5 to 10. Well, the y-intercept just stayed at a 5, so we don't like option C. Option D, the slope of the graph of g of x is 3 times the slope of f of x. So we said that before, 6 is 3 times a 2. But then it says the y-intercept does not change. So this is a 5 y-intercept, and g of x has a y-intercept of 5. So honestly, for a multiple choice question, I think this is a mistake. There are 2 correct answers here, so we're just going to choose both of those. Just know that on the exam, it's not a select all that apply. There will only be one correct answer on an exam question, but that's okay. We'll take both of these. They're both correct, so here we go. All right, number 58. A movie store sells DVDs for $13 each. What is the cost C of N DVDs? Is the graph continuous or discrete? So to find the total cost, what we would do is we would take our number of DVDs N and multiply it by the cost. Each one costs $13. So $13 times however many you are buying. So if we look at our functions, cost equals 13 times N, that one's good. C equals 13 times N, we like that. C equals 13 plus N, nope. And here's a 13 plus N. So we're not going to choose B or D. So what's the difference between choice A and choice C? So the difference here is if the function is continuous or if the function is discrete. So visually, let me just show you what a continuous function looks like. It continues. A discrete function would be individual points like this. That would be discrete. So if we think about the cost of DVDs, would that be continuous or discrete? Well, we can do a little bit of math and figure some of this out. If you buy one DVD, you're paying $13. If you buy 2 DVDs, you're paying $26. If you buy 3 DVDs, you're paying $39. And so what we notice is that our cost is jumping from 13 to 26. It's not including all the values in between. Like a continuous function would include 13.5, 14.7, 16, 17, 18, 20.1. A discrete function will just be 13, just the 26, just the 39. So because of the situation, the cost is just $13 times your number of DVDs. These are the answers we would get, because you can't buy partial DVDs. You can buy one DVD, two DVD, three DVDs. So this is a discrete function. All right, number 57, a movie store sells DVDs for $17 each. What is the cost C of N DVD? So we just went through this up above. So our cost is going to be the price of a DVD times N, the number of DVDs that we're buying. If they had asked a follow-up question, is that continuous or discrete? This one would be discrete as well, because it's the same example. All right, 58, describe the pattern in the sequence. What are the next two terms? So we are going from 5 to 6 to 7 to 8. We can see a pattern of increasing by 1. If you take 5 and you add 1, you get 6. Add 1, you get 7. Add 1, you get 8. We can continue that. If we add 1, we'll get 9. Add 1, we'll get 10. So those are the next two terms in the sequence. And let's see which option describes what we just came up with. Option A, add 1 to the previous term. Yep, that's what we were doing. The next two terms are 9 and 10. All right, well, I like option A. Option B, we're multiplying the previous term by 1, so we did not use multiplication. C, option C, multiply the previous term. Nope. D, subtract 1 from the previous term. If these numbers were decreasing, then, we could think about that, but we were just adding 1 to the previous term, and we found our next two terms. All right, number 59, describe the pattern in the sequence. What are the next two terms? So we're going from 18, we're going down to 14, down to 10, down to 6. So it looks like we are decreasing by 4. If we continue that, 6 minus 4 is 2. 2 minus 4 is a negative 2. So that would be the next two terms in our sequence. And then how could we say that in words? You could say adding a negative 4 to the previous term, or you could say subtract 4 from the previous term. If I just look at the phrasing of the previous problem, I'll just say subtract 4. From previous term. And then the next two terms are 2 and negative 2. Okay, number 60. Determine whether the sequence is arithmetic. If so, what is the common difference? So the common difference is what you are increasing or decreasing by. What are you adding on to the previous term? If your numbers are getting bigger, you'll have a positive common difference. If your numbers are getting smaller, you'll have a negative common difference. So we are going from 16 to 26 to 35 to 44. So is that any sort of pattern there? Well, I think I said 16. I meant 17. So 17 plus 9 is 26. 26 plus 9 gets us to 35. And 35 plus 9 gets us to 44. All right, so you do want to make sure that you are consistent with that pattern through the entire sequence that you're given. So yes, this is an arithmetic sequence, and the common difference is a positive 9. That is going to be option B.